Today we are talking about resolution of vectors, of the various force vectors which are acting on a block placed on an incline. Now the incline exerts a force on the block which is called as the normal force. What is this normal force? The normal force is just a response for the force which the block is exerting on the incline. So you can see what force the block is exerting on an incline. So let's see. First of all, we have the weight which is acting always in the vertically downward direction. So even if the block is placed on a table like this, mg will be downwards. Even if there is a wall and there is an object stuck to it like this, the mg is still downwards. If there is a slope and the object is here, mg is still vertically downwards. So we should never ever get confused with the direction of mg. It will always be vertically downwards. So here I have selected mg and it is like this, vertically downwards. Now I know that this angle is theta and this angle is 90, which makes this 90 minus theta. Okay, so this angle becomes theta. I hope this is understood. This is theta. This is 90 minus theta. This is 90 minus theta because this angle is 90. Okay, so you can also solve it because sum of all the angles of a triangle will give you 180. So this will eventually come to 90 minus theta and this will become theta because this angle is 90 degree. I explained this that when we resolve a vector, we are splitting the vector into two vectors which are 90 degree to each other, right? And this resultant is always in between them. So we got finally that this angle is theta. Since we got this angle is theta, I told you a shortcut that whichever vector is close to theta is mg cos theta and whichever is the another vector, that will become sin theta, or you can also use sin theta is equal to opposite upon hypotenuse and you can get the answer there also, but this is however a shortcut. And now we can see that what force the block is actually putting on the incline. It is mg cos theta because mg sin theta is along the incline. It is not acting on the incline. Okay, it is along the incline. So mg cos theta, block ने incline पे mg cos theta का force लगाया, उसका response incline ने कैसे दिया, उस पे n मतलब नॉर्मल फोर्स लगा के. अब ये नॉर्मल फोर्स को अभी हम लोग ब्रेक करेंगे दो कंपोनेंट्स में विच आर एट 90 डिग्री टू ईच अदर. नाउ वी नो दैट दीज कैन बी कंसिडर्ड टू बी ऑल्टरनेटिंग एंगल्स. दिस इज थीटा, दिस बिकम्स थीटा, this becomes theta, this becomes 90 minus theta, then this becomes theta. So since this is theta, we can say this is n cos theta and this is n sin theta. This was resolution of all the vectors for a block placed on an incline. Now what happens, students, just memorize it that जो इंक्लाइन के अलॉन्ग आएगा वो mg sin थीटा होता है. एंड देन क्या होता है कि क्वेश्चन में कभी कभी वो लोग ऐसा वाला इंक्लाइन दे देते हैं एंड देन पूरा रॉन्ग हो जाता है क्योंकि वो लोग ने याद रखा रहता है कि ये mg sin थीटा होगा, बट इस टाइम ऐसा होता है कि नहीं, वो हमको चेक करना पड़ेगा. ठीक है, सो एवरी टाइम यू गेट अ क्वेश्चन बेस्ड ऑन NLM, so please try to make the diagram. Do not remember that ये force ऐसा होता है, वो force वैसा होता है. Always try to make the only force which will be constant is mg, which is there in the downward direction. Also, if they tell you that there is friction will be in upward direction because friction will always oppose relative motion. Friction never opposes motion. Friction opposes relative motion. This is also a very important point which I will try to explain in detail in one of my videos. So here I come to the end of a resolution of vectors on an incline. Please, if you have any doubt, let me know in the comments. Share karo, like karo, and let me know some suggestions in the comments of which topics you all would like me to teach. So today we are talking about